Good morning students and welcome to our YouTube channel Gnan Manjari Modern School. So in the previous videos we are just going through the chapter, that is chapter number 5, acids, bases and salts. So in that previous video what we are have seen about salt. What are salts? Okay students, what are salts? In that we have seen that acids plus base, acid plus base, which gives us what? Salt plus water. Okay students, acid plus base gives us salt. Okay students, in that we have seen example of common salt, that is HCl. If we take HCl plus NaOH, HCl plus NaOH, then what we get? We get a salt. Which salt? That is NaCl and H2O, that is water. Okay students, that we get. In that we have seen the three types of salt. First, that was acidic salt. So in that acidic salt, what we have seen? We have seen what we have seen. First of all, you speak, but I can't listen, but you just speak that what are acidic salt. Okay students, I am giving you 10 seconds. I am writing the strong acid react with weak base is known as acidic salt. Strong acid reacts with weak base is known as acidic salt. Now moving towards basic salt. So what is basic salt students? Yes, basic salt means weak acid reacts with strong base is known as basic salt. And then after we have seen was neutral salt. Okay students, in neutral salt, what it was? Strong acid reacts with strong base or weak acid reacts with weak base. Okay students, so in the previous video we have talked about the salt, that is how the salt is formed. First of all, acid plus base gives us salt plus water. Okay students, and we have also seen an example of our common salt, that is when the HCl and NaOH is reacted, then we get that is salt, that is NaCl and H2O. How we get NaCl? So here, from here, the positive H and this is negative Cl. Okay students, over here you can see that this negative OH and positive Na, positive Na, negative OH, this Cl combines with Na and this H will combine with OH, H will combine with OH. So what will happen? This will with NaCl, so positive first, so NaCl, and here 2H plus O, that is H2O, it will form H2O. So how this NaCl is formed? Okay students, here Na is positive, Cl is negative. Okay students, and then we have seen was acidic salt. So what is acidic salt? When strong acid reacts with weak base, it is known as acidic salt. And what is basic salt? Basic salt means weak acid plus strong base is known as basic salt. And neutral salt, that is strong acid reacts with strong base or weak acid reacts with weak base, so it is neutral salt. Okay students, if you want to write this main points of the salts, then you can write. And now we will see our new topic, that is neutralization reaction in everyday life. So how this neutralization reaction we use in our daily life? Okay students, let us see one by one. See here, the first is insect stings. Insect stings. Okay students, here we know that bee, the honey bee, when just stings to our body, then it just, we can't bear that. Okay students, then how it, the bee contains an acidic substance in that sting. So if we put a base on it, then it will be neutral, then we don't just irritate off it. See here I am reading that bee sting contains an acidic liquid that get released into the skin on stinging. The acidic liquid is neutralized by applying calamine lotion which contains zinc carbonate as base. Okay students, insect stings means when the bee is sting us, then we have to what apply there? We have to apply zinc carbonate, that is base. So that acid and this base will just neutralized. And soil treatment, how the soil treatment is neutralized? When the soil becomes too acidic for plants to grow properly, basic substance such as quicklime, slaked lime or chalk is added to neutralize the soil. Neutral soil is best for growing healthy crops. So when the soil is too acidic, we have heard about the acidic rain. This will happen there, means due to acidic rain, the soil will be acidic. So this acidic soil is to be neutralized, so we have to add some of the base in it, so it gets neutralized. So neutral soil is best for growing healthy crops. Okay students, our next point is, that is indigestion. Indigestion, we have heard about the acidity. Okay students, the stomach produced a dilute solution of hydrochloric acid for indigestion of food. Sometimes excessive production of acidic leads to indigestion. Antacids such as baking soda or magnesium hydroxide are basic in nature. They neutralize the stomach acid, thus relieve in acidity. We have heard that the old people just say that acidity is there, so some of the base is to be added so that acid gets converted into neutral. When acid and base reacts and it will convert to the neutral, we get relief. Okay students, next is factory waste. Industrial waste may contains many acidic substances which, if left untreated and discharged into a water body, may harm aquatic life. A base such as slaked lime is generally used to treat the waste, neutralizing the acid before releasing it. Means we all know that in the some of the dyeing industry, the acidic substance are used for dyeing, and then after they just drain out in any of the rivers or everywhere. Okay students, then what will happen? Due to this acidic water, these aquatic animals will harm. So what we have to do, there is an slaked lime solution is to be just added in it, so acid when we add it in base and it will be neutralized. Okay students, so the factory waste is to be purified and it not to be harm to our environment. Okay students, see here there is an activity given over here, aims to demonstrate a neutralization reaction. Dilute solution hydroxide, dilute hydrochloric acid, red and blue litmus paper, phenolphthalein, conical flask and dropper. Take 20 ml of hydrochloric acid in conical flask, add a drop of phenolphthalein to it. Now carefully add sodium hydroxide drop by drop to this solution using a dropper until the color changes from colorless to pink. Test the above solution with litmus paper, note down the result. Observation: when the pink solution is treated with litmus paper, red litmus paper turns to blue, indicates the solution is basic. Conclusion: phenolphthalein when in acid remains colorless. When sodium hydroxide was added to dilute hydrochloric acid drop by drop, the base was neutralized by the acid. At the end, the last drop of the sodium hydroxide changed the color of phenolphthalein to pink, indicates that the solution was now basic. The color change in the litmus paper also indicates a basic solution. Means in this activity we have to take the dilute hydrochloric acid and a base, and when we just adding in the dilute hydrochloric acid, when we are just adding, first of all we have to add phenolphthalein, then after we have to add drop by drop sodium hydroxide so that it will be neutralized, and then after some time if you add and add, then it will be basic. So the color will change to colorless to the pink, so we can know that it is a basic substance, basic, it converts to base. Okay students, now there is an properties of salt. Let us see one by one all the properties of it. So the properties of salt, let us see that students. Properties of salt. Properties of salt. Let us see one by one all the properties of it. See here, first of all reading the first property of salt, that is salts are generally known to have high melting and boiling temperatures. Okay students, so the first point, that is salts are generally known to have high melting and boiling temperatures, Okay students, so the first property is the salts have high boiling point and melting point. If the salt is in the liquid form, then its boiling point is high, and if the salt is in the solid form, then its melting point is at high range. Okay students, let us see our next point, that is most of the salts are soluble in water. Okay students, most of the salts are soluble in water. See here, some of the examples are given over here, that is sodium chloride, sodium carbonate, potassium nitrate, ammonium sulfate, ammonium carbonate. Salts that are insoluble in water are silver chloride, lead sulfate, copper carbonate, etc. So, the salt which are not soluble in water are silver chloride, lead sulfate and copper carbonate, etc. Okay students, and our next point and or next property, that is some salts that forms crystal generally contains water molecule within them. This water is called water of crystallization. Okay students, and such salts are called hydrated salt. Okay students, see here, what is it? First of all, let us see the property again. Salts are generally known to have high melting point and boiling points. most of the salts are soluble in water, but some are not soluble in water. We have seen that examples. And see this point, some salts that forms crystals generally contains water molecule within them. This water is called water of crystallization. What? Water of crystallization. You have to just see, and such salts are known as hydrated salt. So if somebody asks that what is hydrated salt, then you have to say that the salt that forms crystals, the salts that contains water molecule within them, they are known as hydrated salts. What are hydrated salts, students? Salts that contains water. Okay, students, salts that contain water molecule within them, they are known as hydrated salt. Okay, students, going towards next, hydrated and anhydrous salt. Before that, there is an example of it. Let us see that. For example, hydrated copper sulfate contains 5 water molecule per copper sulfate molecule. The chemical formula is written as CuSO4 into 5H2O. Okay, students, now let us see the hydrated salts and the anhydrous salts. So, hydrated salt. What is hydrated salts? See here, the definition is written over here. Writing it again. So, what is hydrated salt and anhydrous? Hydrated and anhydrous salts. Okay, students, in that hydrated salts, that is salts that contains water of crystallization water of crystallization are called hydrated salt. Okay, students, are called hydrated salt. The water of crystallization gives to the salt a crystal. It also gives color to some crystals. See here, when heated, such salts loses their water of crystallization, thus losing their shape and color. They changes to the powdery substance. Hydrated salt have lost their water of crystallization are called anhydrous salt. Okay, students, what is anhydrous salt? Let us write that. Hydrated salt that have lost their water of crystallization are called anhydrous salt. Okay students, see here, what is hydrated salt? Salts that contains water of crystallization are called hydrated salt. See here, and what is anhydrous salt? Hydrated salts that have lost their water of crystallization are called anhydrous salts. Okay students, now see here, reading the examples of it. For example, hydrated copper sulfate is blue in color. See here, the picture is given over here. When heated, this salt loses its water of crystallization and forms a powdery substance called anhydrous copper sulfate, which is white in color. Okay students, see here, some of the hydrated salts and their chemical formula and uses are given. You just see it at your home. Okay students. Now next, please note down your today's homework students. So your today's homework is, we have just finished this chapter. Okay students, and in next video what we will do is, we will just revise whole chapter and we will just, I will write the answers of the objective. Okay students, I will write the answers of the objective. So your homework is, find out the answers of exercise objectives. Okay students, in next video I will say the answer, you just verify it. Okay students, up till then stay safe, stay home. Okay, bye students.